Hi, everyone. This week, we're going to move into talking about a really special type of function that we call a piecewise function. Piecewise function is really interesting because it is actually very connected to linear functions, which we talked about way at the beginning of the year, but it's going to dive a little deeper into a more complicated type of function. But it's actually pretty interesting, and you can do some pretty cool things with piecewise functions. So there will be some review that is needed for this, which we'll go over at the beginning of this video. And then this week, we have 4 main goals that we'll need to do with these piecewise functions that we're talking about. So the first thing you're going to want to be able to do is write a piecewise function in point slope form. So the video is going to review what point slope form is, and it's also going to explain and give some examples on how to write a piecewise function in point slope form. The other thing you're going to have to be able to do is evaluate a piecewise function. Now remember, evaluate means to solve, so really we're looking at this idea, can you solve a piecewise function? We're also going to be looking at the domain of piecewise functions. So the values on the x-axis that make our function possible. So those are the 4 things that we're really going to be focusing on. Can you write equations for piecewise functions in point slope form? We're going to review point slope form. Can you evaluate a piecewise function, and can you describe the domain of a piecewise function? So the video is, I will warn you, it is long, but it goes over all 4 of those pieces. Just to kind of give you some context, if we were in the classroom doing this, we would probably spend a good 2 to 3 days learning all of these concepts. So we're taking all of those lessons and combining it into about a 20-minute video. So hang in there with me. If at any point you start to feel like you understand and you want to fast forward a little bit, definitely go ahead and do that. But each example will directly connect to something you will be assessed on the quiz. So just kind of keep that in mind. As always, we want to make sure that you are taking notes as you're watching the video. So make sure you have something to write with and paper to take notes on. And if you don't, pause the video, go grab that, and then come back and we will get started. This week, I'm going to share with you a Google Slides presentation, but I'm also going to share my camera like normal. So be a little patient with me as I flip back and forth between them, and we will get started. So we're gonna get started with our equation here, our presentation here. Oops, sorry about that, wrong button. And we're gonna talk about what we're first going to review point slope form. So you can't really talk about piecewise functions unless you're talking about point slope form. So let's review what point slope form is. Point slope form is used for linear equations. Now remember, linear equations are straight line equations that have a constant rate of change, also known as a slope. So when we talked about point slope form way back in the fall, we found that this was our formula for point slope form. As long as you know the slope and you know any point on that line, you can plug in those 3 values, and now you have point slope form. We're going to use a version of this for piecewise functions, but we're going to modify it slightly to make it a little bit easier to work within the function this week. So what you'll notice is I'm going to start with our original formula. So this was the formula we just looked at. Y minus the y value equals m, or the slope, times x minus the x value. But my goal is to get the y by itself. So I'm actually going to move the y coordinate over to the other side. To do that, I just do the inverse operation to get rid of it on the left side. So I'm going to add the y coordinate, the y1 value, and by doing that, it's going to give us this equation here in the box. This equation is what we're going to use for our piecewise functions this week. So this is an equation I would highly recommend you take a quick pause and write this down. This equation this week says y equals m times x minus x1 parentheses plus y1. So let's label each of these parts. We know that the m represents the slope. The x1 represents the x coordinate of a point on our line. And what we notice here is it's the opposite. So if your x coordinate is positive, you're actually going to put a negative in the parentheses. If your x coordinate is negative, you're going to put a positive in the parentheses. So whatever your x coordinate is, you plug in the opposite. And then finally, we have our y coordinate, and we'll notice that's the same. If your y value is positive, it stays positive. If your y value is negative, it stays negative. So this equation at the bottom is something that you will really, really need this week. So make sure you have that written down, and you can add the labels there if you want to as well. Now that we know point slope form, we can move into talking specifically about piecewise functions. So let's think for a second. What is a piecewise function? Well, I noticed that it has the word piece in it, and that's actually kind of our clue of what a piecewise function is. A piecewise function is a function that's defined or made up of multiple sub-functions. In other words, lots of little functions, whereas each sub-function applying to a certain interval of the main function's domain. Okay, that's a lot of mathematical words that essentially just says a piecewise function is made of multiple little functions over a given domain. Now remember, domain are x values. So what does that look like on a graph? Here is an example of a piecewise function. You can probably see why we call something like this a piecewise function, because it's made of little pieces. Each of my pieces is a straight line, so it has a constant slope, but they're all connected to make one larger function. When you're looking at a piecewise function, we want to analyze how many pieces does that function have. So I'm going to look and see each of the parts of my function. I notice it starts here and it goes down with a negative slope. That creates my first piece. Then goes straight across. It has a slope of 0. That creates my second piece. And then it goes up for a positive slope, which creates my third piece. So this piecewise function is made up of 3 pieces. Now, just like normal, we're going to quickly review domain because domain is really important. What is the domain of this function? Well, remember, when you're looking at the domain of a function, you're looking at the x values where that function works. So where does it start on the x-axis and where does it stop on the x-axis? So I notice it starts here. That value is connected to the x value of -3. So that's where I put in my domain starts. The function then ends all the way to the right at 4, which is where my function ends. So the domain of this function is -3 is less than or equal to x, which is less than or equal to 4. Let's take a closer look at another piecewise function. Now this piecewise function, again, has 3 pieces. This time I color-coded them for you so you could easily see which pieces where. So I have a red piece that starts, a blue piece in the middle, and a green piece at the end. 3 pieces. I'm actually going to show you what the equation for this piecewise function looks like, and I want you to notice connections or similarities that you see between the graph of our piecewise function and the equation of our piecewise function. Okay, so here's our equation. Hopefully one of the things you notice is that the graph has 3 pieces and our function has 3 parts too. I see a big equation at the top, I see a second equation in the center, and I see a third equation at the bottom. What you're starting to notice is that every piece in our piecewise function has its own mini equation and its own mini domain. We just put them together in this curly bracket. So let's look at how we can write our little mini equations for each of our pieces. Let's start with the red piece. In point slope form, you need to know the slope and a point. So those are the first 2 things I'm going to look for. I'm going to look at the slope of my red piece. I notice it has a slope of 2. Remember, rise over run. It rose 2, it ran 1, so a slope of 2. And I'm always going to look at the starting point. That's going to be really helpful in our piecewise functions. So where does this piece start? It starts at this point here, which is -4, -7. So now I have what I need to plug into my equation of point slope form. The third thing I need, though, is what we call a domain restraint. So you'll notice here in this first equation in italics, it says if, and then it has a little mini domain. Where does this piece start on the x-axis, and where does this piece stop on the x-axis? Well, the red piece only starts at -4 and ends at -2. So the domain of this little mini piece is -4 is less than or equal to x, which is less than or equal to -2. And now I'm just going to plug everything in. I have a slope of 2. I have a -4 x value, so it becomes a +4, and a -4 y value, which stays the same, -7. And then within my domain of -4, which is less than or equal to x, which is less than or equal to -2. And that's it, then you're done. We're gonna move on to the second piece, which is our blue piece. Again, we're looking for the slope, we're looking for the starting point, and we're looking for the domain. And once I know those three things, I can plug them into point slope form among that domain. So the slope of this piece is 1/2. It rose 1, it ran 2. So it has a slope of 1/2. The starting point is -2, -3, and the domain starts at -2 and ends at +2. So now I have my three things that I'm going to plug up here into my second equation. Slope of 1/2 times x plus 2, I did the opposite of my x value, -3, I did the same as my y value, if, and then I just plugged in my domain, -2 is less than or equal to x, which is less than or equal to 2. We're going to do the same thing one more time, but this time we're going to do it with our last and final piece, our green piece. Again, we're looking for the slope, the starting point, and the domain. So looking at my green piece, I notice the slope this time goes down 1/1, which makes a slope of -1. The starting point is here, which is the point 2, -1, and the domain starts at 2 on the x-axis and ends at 5 on the x-axis. So I have my three things, and I'm going to go plug those into my equation. I have a slope of -1 times x minus 2, did the opposite of my x value, parentheses, -1, I did the same as my y value, if, and then I plugged in my domain, 2 is less than or equal to x, which is less than or equal to 5. So I was able to write an equation and domain for each of my pieces, and then I put them all together to make one big piecewise function. Okay, let's practice actually writing some of this on our own. So when we're writing this on our own, we're looking at each of the pieces. So I have a piecewise function here. I'm going to transfer over to looking at my document camera so that you can see how this is going to work. Okay, sorry, let me zoom in really quick. I can get this, oh, here we go. Okay, so here's the graph that we were looking at on our equation, on our slides, which is here. And what I want to do is I want to write an equation for each one of my pieces here. See how I did that? So what I have to do is I'm really looking at those three things. So the first thing I want to ask myself, let me actually switch the view of this camera. I think it's a little bit hard to see the way that it is. Sorry about that, guys. We're going to go. Oh, I think that will make things a little bit easier. Thanks for hanging with me while I switch my camera. Okay. All right. That way you can see everything all at once. Okay, so here I have my graph, and I'm first going to ask myself, how many pieces does this graph have? Well, I notice that this first piece here, we're going to call our red piece, one piece. Then my second piece, I'm going to call my blue piece. And the last piece, I'm going to call my green piece. So this has a total of 3 pieces. So let's start first with our red piece. Let me get the colors that match here. Okay, so let's look at piece 1. We're going to use, that's our red piece. Again, we're looking for the slope, the start, and the domain. Okay, the slope. Any 2 perfect points, rise over run. I'm going to rise 1, 2, 3, run 1. So this has a slope of 3/1, which is 3. The start, I'm looking for the starting point, which is x comma y, 0 comma 0, it starts right here. And the domain, where does it start on the x-axis and where does it stop on the x-axis? I notice that it starts at 0 and it ends at 2. So my domain is going to be 0 is less than or equal to x, which is less than or equal to 2. So now I have everything I need to plug into my equation. Now remember, here's our point slope form. So we're just going to plug that all into our equation. Y equals, remember, m is slope, so 3 times x, and then this represents our x value, which is 0, minus 0. Y represents our y value, which is 0, plus 0. If, and now we do our domain, we just rewrite it. 0 is less than or equal to x, which is less than or equal to 2. Okay, so we got piece 1 done. Let's move on to piece 2. Piece 2 is our blue equation. So let's do our blue equation. What's the slope of this piece? Rise over run. It rises 1, 2, and it runs 1, 2, 3. So it rises 2 over 3. Start, here's the start point right here. That's where this piece starts. What point is that? 2, 6, it looks like. I see it, 2, 6. 2, comma 6, and domain. Where does it start on the x-axis? It starts at 2. Where does it end on the x-axis? 5. So I have a domain of 2 is less than or equal to x, which is less than or equal to 5. Oh, sorry, probably can't see any of that. There we go. See my screen. Okay, again, we're just going to plug it all in now. Here we go. Y equals m represents our slope, 2/3 parentheses. X, what's our x value? 2, so we plug in the opposite, minus 2, then I'll do our y, keep it the same, plus 6. If, now do our domain restraint, if, just plug it in, 2 is less than or equal to x, which is less than or equal to 5. All right, piece 2 is done. Last but not least, we're going to do piece 3. Get that up there for you. All right, piece 3, that's our final piece, that's our green piece. Okay, here we go. What's the slope of this green piece? I see this one goes down 1, 2 over 1. So this has a slope of -2. The green piece starts at this point here. That point is 5, 8. So we're going to write 5, 8. What's the domain? This starts at 5. So 5 is less than or equal to x. And it ends at 8, which is less than or equal to 8. All right, we got it all. So now we're ready to plug everything in. And again, we're going to use, can't really zoom out anymore, but remember our equation. See if I can get it here. Here we go. Y equals m is slope, -2, parentheses, x, plug in the opposite of our x value, -5, plug in the same as our y value, plus 8, and then do our domain restraint, if, and then plug that in, 5 is less than or equal to x, which is less than or equal to 8. Whew, all right, we got piece number 3. The final thing we're going to do is put all of those equations together. So you have equation 1, equation 2, and equation 3. So what I'm going to do is I'm just going to write them all together as one big function next to my graph. We have f of x, that's our function, equals, and I'm going to do a big bracket because there's 3 pieces. Piece 1, I'm just going to copy it straight down. I'm going to write small so we can fit it in there. I don't have to do the y equals because I already have the f of x here, so I'm just going to start here. 3x minus 0 plus 0, and I'm going to do it underneath because I'm running out of room, if 0 is less than or equal to x, which is less than or equal to 2. Equation 2, 2/3 x minus 2 plus 6 if 2 is less than or equal to x, which is less than or equal to 5. Oh, my bracket wasn't long enough. I'm going to make it longer. Let's do our last and final green equation here. Negative 2x minus 5 plus 8 if 5 is less than or equal to x, which is less than or equal to 8. Woo! Look at that equation. You just wrote a piecewise function for a 3-part function. Part 1, part 2, part 3. Okay, so now we know how to write a piecewise function. Sorry, one sec. Okay, now we know how to write a piecewise function. We still have to talk about how you evaluate a piecewise function. So that's going to be the next thing we're going to work on. So we just practiced writing our piecewise function. Let's move into evaluating our piecewise function. Now remember, when you evaluate, that really just means you're solving. So you have to solve a piecewise function. So what does that mean? Well, it looks like you're solving for the y value. So we remember this way back from the fall. This says f of 1. You have to figure out what is f of 1. If the input or the x value is 1, what comes out? What about this one, f of 7? If I plug in 7 to my equation, what comes out? Now it's a little bit easier to do on a graph, but for this week, it's really important that we know how to do this using the equation. So I'm going to go back to the equation that represents this graph that we just wrote and show you how to evaluate using that. So we're going to share. Okay, so here's the equation that I just wrote for my piecewise function. We just wrote this previously. So what we're trying to do is evaluate for f of 1. We're trying to figure out when x is 1, what is y. Your first step is to look at the number that you're inputting, and you have to find which piece should you use. This number you have to look for within your domains. Does the number 1 fall between 0 and 2, or 2 and 5, or 5 and 8? Well, I know the number 1 is between 0 and 2. So I have to use piece number 1. That's the equation I want to use. That equation is 3 times x minus 0 plus 0. What I'm going to do is I'm going to take the number I want to plug in, and I'm going to plug it in for x. So if I want to figure out what y is when x is 1, we're going to plug in 1 for x. So this equation becomes 3 times 1 minus 0 plus 0. And now I can just simplify. 3 times, what is 1 minus 0? Just 1 plus 0, which doesn't really mean anything. So I'm left with 3 times 1 equals 3. So that is the answer to f of 1. We know that f of 1 equals 3. You figure out what piece you use, and then you just plug it into the equation. That's all you do. Let's try the next one. The next one says f of 7. So I want to plug in 7. So first step, figure out which piece to use. Where does 7 fall within the domain? Is 7 between 0 and 2? No. Is 7 between 2 and 5? No. Is 7 between 5 and 8? Yes. So I want to use piece 3. So look at equation for piece 3, which says negative 2 times x minus 5 plus 8. And again, we're going to take that equation and plug in our number that we want for x. This case, our number is 7. So again, we're just going to rewrite. Negative 2 times, instead of x, we're going to plug in 7. Then keep going, minus 5 plus 8. And now all we do is solve. Parentheses first, negative 2. What is 7 minus 5? 2 plus 8. Negative 2 times 2 is negative 4 plus 8. What is negative 4 plus 8? That's positive 4. So what's my answer here? F of 7 equals 4. Kind of making sense? Let's do one more example. This example wants us to find, this problem wants us to find f of 5. F of 5. Okay, so let's see which piece we should use. Does 5 fall between 0 and 2? No. Does 5 fall between 2 and 5? Yes, because this piece here says less than or equal to 5. So I could use piece 2, but take a look at this. This also says 5 is less than or equal to. So this is kind of a fun one because you can pick which equation you want to use. Do you want to use piece 2 or do you want to use piece 3? I'll tell you, I see a fraction in piece 2. I don't really want to use piece 2. Fractions are not super fun to work with. So I'm going to plug in to piece 3. It's up to you though. If you want to plug into piece 2, that's fine. You're going to get the exact same answer. So I'm going to use piece 3. Use piece 3. Again, it's the same equation. I'm going to write that equation down. Negative 2 times x minus 5 plus 8. But again, instead of x, we're going to plug in the number for our input. I'm going to zoom in a little bit just so you can see better. I want to plug in 5, so rewrite negative 2. Instead of x, we're going to plug in 5. Finish our equation. Minus 5 plus 8. And now we're going to solve. Negative 2. What's 5 minus 5? 0. Finish the equation. Plus 8. Now multiply. Negative 2 times 0 is 0 plus 8. What's 0 plus 8? 8. So if I have f of 5, what do I get? F of 5 equals 8. These are 3 examples of how you can evaluate a piecewise function, how you can solve a piecewise function. Remember, you're focusing on this idea. You have step 1, figure out your piece. Step 2, plug in your x value that you're trying to find. And then step 3 is to just solve. Okay? So that's how you evaluate a piecewise function. We're going to go back to the Google Slides really quick because we're going to evaluate just from here. So let's see, take a second, maybe pause the video, try these on your own once I show you the problems, and then we'll go over the answers together. So you'll see I have a new piecewise function here, and we're going to practice evaluating just like we learned. Okay, so the first problem is evaluate f of negative 3. So if you want to try this on your own, pause the video and then check your answer. If we're trying to find f of negative 3, again, I have to figure out which piece do I plug it into. Does negative 3 fall between negative 7 and negative 5 for piece 1? No. Does negative 3 fall between negative 5 and negative 2? Yes. So I know I want to use piece 2. I'm going to plug in my x value to my equation. So I'm going to say negative 1 times, instead of x, negative 3 plus 5 minus 5. Then I just get to solve, and I got negative 7. Check my work. So I evaluated that f of negative 3 is negative 7. Let's try one more problem. What about this one, f of 3? Okay, first figure out our piece. Does 3 fall between negative 7 and negative 5? Nope, it's a positive, not a negative. Does 3 fall between negative 5 and negative 2? Nope, it's a positive, not a negative. Does 3 fall between negative 2 and 3? Yes, but I noticed piece 4 also says 3. But here's the thing. Piece 3 says less than or equal to 3. Piece 4 just says 3 is less than, so I have to use piece 3. Now, piece 3 is pretty nice. I would have picked it anyway if I had the choice, because you'll notice the equation just says y equals negative 3. There's nothing to plug in. It gave you the answer. So if I plug in 3, what do I get? Negative 3. If there's no x there, there's nothing to plug in, you have nothing to solve. It gave you exactly what your answer is. Your answer is just 3. Okay, how are we feeling about evaluating? Hopefully pretty good. Let's talk about domain. This is kind of the last thing we're going to do for this. I want you to be able to describe the domain of this piecewise function. And you might say, well, Miss Segovia, there's no graph. How do I know what the domain is if I can't see the x values? Well, it's actually hidden in our piecewise function. We know domain represents our x values. Well, remember, each piece has its own little mini domain connected to it. The domain of the overall function tells us where the function starts and where the function stops. In this function, I notice my first piece starts at -7. So that tells me my whole domain is going to start at -7. And then piece 1 goes from -7 to -5. Piece 2 goes from -5 to -2. Piece 3 goes from -2 to 3. Piece 4 goes from 3 to 7, and then it ends. So what's the very last x value that my function has? 7. The first x value in our domain tells us the start of the overall domain. And the last x value of our last piece tells us the very end of our function. So you just can plug those in. This domain of the entire piecewise function goes from -7, where it starts, to 7, where it ends. Again, it's just the first domain value and the very last domain value. Wow, we just did a lot of things with piecewise functions, and you hung in there and waited a really long time through all those examples. If you've made it this far and you're still hanging with me, I highly recommend that you do the practice quiz and you do some practice problems, maybe even watch the video again before taking the graded quiz. The content this week is difficult. Don't forget, your teachers also have our check-in, our live check-in over Zoom, where we're going to go over more examples of this to help you prepare, and you can see us on Tuesdays and Thursdays at 12:45 to 1:30. So you guys did a really good job this week. I'm really excited to see how your content goes this week. Make sure you email, ask us questions if you have them. I know it's a lot and overwhelming, but please don't give up. I know you can do this if you do some practice. And we're here to help you however we can. Have a wonderful week and great job taking notes on this week's content. We'll talk to you soon.